everyone, I'm Kashish and I'm presenting my project on antibacterial and antioxidant activity of garlic, scientifically known as Allium sativum. Garlic is commonly used spice and food ingredient that has also been widely studied for its medicinal properties. It is known for its antibacterial, antioxidant, anti-inflammatory and other biological activities. According to literature, these effects are mainly attributed to a compound called allicin, which is formed when garlic is crossed through the axon of the enzyme allinase, converting allicin into allicin. Allicin, chemically known as diallyl thiosulfinate, is responsible for garlic's characteristic odor and is considered the major compound contributing to its antimicrobial and biological activities. However, allicin is highly unstable and can degrade quickly into other sulfur-containing compounds, which makes its detection and role in biological activity difficult to confirm. The hypothesis of this study was that fresh garlic extract exhibits both antioxidant and antibacterial activity against gram-negative bacteria E. coli K12 as enterica and gram-positive bacteria Acerus. The objectives of my research were to extract garlic and analyze allicin using UPLC, test the antioxidant activity of extract using DPPH and FRAP assays, and test the antibacterial using agar-well diffusion and MEC assays. Moving to methods, extraction was simply done using just HPLC grade water with crossing garlic, homogenizing and centrifuging the sample to get the extract. Two common antioxidant tests were done, DPPH and FRAP. Antibacterial property was evaluated using agar-well diffusion method. In addition to just aqueous extract of garlic, raw sliced garlic and crossed form of garlic were also tested against all three bacteria and the zone of inhibition was observed. MEC test was done to determine the minimum inhibitory concentration by testing serial dilutions of the sample to find the lowest concentration that prevents the bacterial growth. UPLC was also used to detect the presence of allicin on the sample following the methods from a literature. Results from antioxidant activity and UPLC. The free radical scavenging capacity of the garlic extract from the DPPS assay was found to be 3.31 micrograms per ml garlic acid equivalent per gram of the starting weight, and the ferric reducing ability of the garlic extract in the presence of metal ions from the FRAP assay was 5.03 micrograms per ml garlic acid equivalent per gram, indicating limited antioxidant activity under the conditions used. Regarding allicin detection, no prominent peak was observed at 240 nanometer in the UV spectrum of the aqueous garlic extract. However, literature reports that allicin typically shows a peak around this wavelength. Allicin may have been present below detection limits or may have degraded into other sulfur-containing compounds that contribute to the observed effects. The antibacterial assays showed clear zone of inhibition in all tested bacteria for all garlic treatments, as you can see in figure 1E to 1C. Zone of inhibition in radius from the hole were observed ranging from 2 mm to 8 mm across all treatments tested. The crushed form of garlic showed the strongest antibacterial effect against all three tested bacteria, while the aqueous extract was significant only against Acerus. Acerus was the most susceptible to garlic compared to E. coli K12 and Enterica. The MEC test showed that garlic extract inhibited Acerus up to a 1:3 dilution and E. coli and Enterica up to 1:2 dilution, following the same trend observed in the agar-well diffusion assay. Overall, garlic demonstrated strong antibacterial activity against all tested bacterial strains, particularly in its crossed form, while showing limited antioxidant capacity under the conditions used. Although allicin is widely reported in literature as the primary bioactive compound in garlic, It was not detected in the aqueous extract in this study, suggesting that either it was present below the detection limit or had degraded into other sulfur-containing compounds. Despite this, significant antibacterial effects were observed, indicating that these secondary compounds may play an important role in the biological activity of garlic. Future research should focus on identifying the exact compounds responsible for the antibacterial effects observed as allicin was not detected. Researchers working on garlic could use more advanced analytical techniques along with proper standards to detect and characterize sulfur containing compounds formed after allicin degradation. It will also be useful to optimize extraction conditions such as temperature and solvent type to prevent the loss of unstable compounds. If the main active compound responsible for these effects is successfully identified, it will be highly beneficial as it could open new possibilities for the use of garlic derived compounds in medicine. Finally, I would like to thank Dr. Jessica Livingston, Dr. Michael Gibson, Marla McKenzie, and Crystal McFadden for their guidance and support throughout this process. I'm also grateful to the institution for providing the facilities and resources necessary to carry out this study. Thank you.